Hi, I'm Chris, and welcome to a quick demonstration of the Rock, Paper, Scissors Lizard Spock smart contract created for the cryptocurrency class of 2022. Let's have a look at how our smart contract works. I've already deployed it to my JavaScript virtual machine using Ethereum Remix IDE, and we can interact with it right here. So first we want to start a game, and to start a game we need to submit a hidden move. Here in the documentation we can see how this hidden move is created. Essentially we use a move. So for now, let's use a move of 0, which is rock, and a random nonce. For simplicity, let's just use 1 right now. Obviously, this should be much harder to guess in reality. Now, the data that we get is the data that we will send into our start game function. And also we need to send along some ether because we need to make a bet, which will be matched by our second player. And also we need to make a safety deposit to ensure that we also reveal our move. So we will get back our safety deposit. Okay, so the game is started now. So now we need a second player. Let's switch our accounts here. And the second player will now call the join game function. We can see that this move can be submitted in clear text. So we will use a move of 1, which is for paper. And also we will need to send along our bet, which needs to match the first player's bet. So 1 ether was the safety deposit and 1 ether is the bet. So second player will match this 1 ether bet and send it to the contract. Okay, so now both players have submitted their move. Now it's time for the first player to reveal their move. So we switch back to the first account and we have a look at this reveal move function. So what we now need to do is we need to submit our move and our nonce. And this will reveal the move and obviously end the game because now both moves are known to both players and the game will decide which move has won. So we can see here in our events, we have a winner event for the address of player 2, and player 2 has won 2 ether, first player's bet and second player's bet. Okay, now let's have a look at a few safety features of the contract. So the first safety feature you already saw is that the first player will submit their move in an encoded format, a hidden move. And we can see here how this is created. So essentially we need a move and a random nonce, and both of those are hashed using the Ketchik256 hash function. So it's impossible for anyone to know what the move is if they don't know the nonce, which means it's very important that we have a random nonce that is hard to guess. The second safety feature is the safety deposit that we already talked about. So if we have a look at our reveal move function, we can see that only if this reveal move function is called, the first player will actually get back the safety deposit. So if they do not reveal their move, then the safety deposit will not be refunded back to them. So the first player is incentivized to actually reveal their move. Next safety feature is a timeout for this contract. So this contract actually always stores the timestamp of the last action that took place. And if this is bigger than the timeout here, so we add the timeout to the last action timestamp, and if this is bigger than our current time, then the timeout has occurred and the game can be completed without waiting for the move of the player whose turn it is. This is obviously very important so that nobody can lock up the contract for eternity by just not submitting their move. And the last safety feature that we can have a look at is in our withdraw function. So this is actually what pays the users their balances back. And we can see that this function actually uses the paradigm from the lecture. So first of all, we have the checks. Afterwards, we have the effects. So we update our balance here already to 0. And only then we have the interaction with the target. So this is actually guarded against reentrancy attacks here. Well, this concludes the demonstration of the smart contract. I hope you found it interesting. If you want to try it for yourself, this smart contract is actually deployed both on the Rinkeby and the Kovan test networks. So here you have the address for the Kovan test network, and here you have the address for the Rinkeby test network, and it's also available on my GitHub, so feel free to check it out. I will also put all of those links into the video description. Thanks a lot for your attention and keep having fun. Bye-bye.